Okay, so now let's define the Nash equilibrium of a Bayesian game. So the Nash equilibrium of a Bayesian game is the same as the Nash equilibrium of a strategic game, in which we just modify the game as follows. So consider a strategic game in which the players, instead of I, being defined by I and Ti. So where I is the player in the Bayesian game and Ti is the type of that player in the Bayesian game. That pairing together will create a particular player. So a particular player in the strategic game is player I of type 1. Another player is player I of type 2. They're like different players. The actions have to be defined for each player in this game, and here a player consists of both player and its type. And the actions available to that player will be, in the strategic game, will be the same as the actions available to the player in the Bayesian game. The preferences are a little more complicated because there's this uncertainty about players' types. The types basically correspond to the signals that can be generated in the world and the states of the world which correspond to those signals. So a state of the world is a particular game that is being played out, and signals can give you an indication of what game is being played out. So the preferences will be given by a utility function that looks like this. So what this statement says in English is that the expected value of the utility that a player I type Ti receives from playing an action AI is a sum where you're summing over all, this is small omega, this is capital omega, so you're adding it for each state of the world. Small omega is a particular state of the world. Capital omega, this, is the set of all states of the world. So you're just adding up over all of the states of the world. This here is a probability of the state of the world being omega given the signal Ti. When you're adding all of this up, you will weight that sum by the probability of that state of the world actually occurring given the signal Ti. This here is your utility function. Now usually in Bayesian games, the utility function depends on the action and the state of the world, the action profile. The action profile defines the actions for all types. And so here, that's exactly what this part of the utility function is. This is the action profile. This is the action that player I is taking, the action that we're considering here, and this A minus I hat given omega is the action profile that players other than player I are expected to play in the state of the world omega, so in the game omega. And then of course the utility function depends upon which game is actually being played and not just the action profile. So that here is the Nash equilibrium for a Bayesian game. Before we move on to the next video, what I want you guys to do is exercise 282.2. And again, the solution to this exercise will be given in your, it's in that solutions textbook on Canvas. I'm just going to hold this in front of you so you can see it.